Hello and welcome you all. Dear students, this topic is link budget analysis and teletraffic. It is unit number 4 from the subject cellular networks. Now, as far as this session is concerned, the terms related to teletraffic and numericals on teletraffic are most important. So we'll start the session with link budget, rather it is link power budget. इसका मतलब क्या है? जैसे let us make it simple. एक ट्रांसमिटिंग स्टेशन है, बेस स्टेशन है, वहां से सिग्नल ट्रांसमिट होगा, इट विल बी कैप्चर्ड, इट विल बी रिसीव्ड एट द मोबाइल रिसीवर. वहां तक सिग्नल में बहुत सारे फैक्टर्स हैं जो अफेक्ट करेंगे, दैट विल कॉज लॉसेस इन द सिस्टम. तो वो सब कैलकुलेट करके ये डिजाइन किया जाता है कि व्हाट शुड बी द ट्रांसमिटिंग पावर फॉर द ट्रांसमिटिंग एंटीना एट द बेस स्टेशन. तो उसका ये लिस्ट है. सो वी आर कंसिडरिंग वेरियस फैक्टर्स. The first factor is transmitted power. It is denoted by PT, जो हमें कैलकुलेट करना है, and all the values are in dB, decibels. तो सब वैल्यूज dB में, इसलिए मैंने हर एक के लिए dB नहीं लिखा है. So we need to calculate transmitted power. Then there is one more parameter. This is transmitting antenna gain. TX stands for transmitting. So transmitting antenna gain, which is denoted by GT. अब देखो ये जो है, ये ट्रांसमिटिंग एंटीना गेन, मतलब जो एंटीना यूज कर रहे हैं ट्रांसमीटर एंड पे, बेस स्टेशन पे, वो कुछ गेन प्रोवाइड कर रहा है. सो दैट दिस वैल्यू शुड बी कंसिडर्ड टू बी पॉजिटिव. मीडियम लिंक प्रोपोगेशन लॉस, मतलब जो मीडियम के थ्रू लिंक, मतलब क्या है? सी, we want to transmit the signal from base station antenna to the mobile receiver, to the mobile handset. तो बीच का जो है that free space which is acting as a link. So link propagation loss, we know that as the distance from the base station goes on increasing, then attenuation in the signal goes on increasing. So this represents the propagation loss. Then system margin. System margin क्या है? While designing, you need to consider some extra losses that are not listed here. So that is called a margin. मतलब एक बार डिजाइनिंग कंप्लीट करने के बाद पर्पजली कुछ एक्स्ट्रा लॉसेस भी कंसिडर करते हैं ड्यू टू चेंज इन वेदर कंडीशंस एंड सो ऑन. दैट इज कॉल्ड द सिस्टम मार्जिन डिनोटेड बाय M. देन एट द रिसीवर साइड, at the mobile station, matlab in case of handset we have a receiving antenna. So that antenna is having a gain which is RX, means receiving end. So RX or receiver side antenna gain, that is GR. ये gain है, इसलिए ये भी वैल्यू पॉजिटिव कंसिडर करेंगे. So this value, first two values are positive as well as RX antenna gain GR is also positive. केबलिंग लॉस, जैसे लास्ट यूनिट में हमने लर्न किया है कि बहुत बार सेलिंग कंसेप्ट में, मतलब जो माइक्रोसेल्स यूज करते हैं उसमें केबल्स यूज करते हैं, इधर फाइबर ऑप्टिक केबल और माइक्रो लिंक्स एंड सो ऑन. तो उसमें जो लॉसेस है दैट इज द केबलिंग लॉस डिनोटेड बाय LE. प्लस एट द रिसीवर साइड देयर कैन बी नॉइज, addition of noise, or there can be interference. In the last unit we have discussed various types of interference like channel interference and so on. So that need to be considered. This is a loss. And required signal to noise ratio. Signal to noise ratio. देखो जो factors है, ये स्टार जो मैंने मार्क किया ये पॉजिटिव फैक्टर्स है, they are providing gain and all that. बाकी सब नेगेटिव फैक्टर्स है which are causing losses, which represents noise. So जो required signal है and its ratio to the noise is called signal to noise ratio, denoted by SNR. So it is required signal to noise ratio. अब देखो बहुत सिंपल है, मैंने लिस्ट बनाया है क्या क्या फैक्टर्स है. सो रिक्वायर्ड SNR, रिक्वायर्ड सिग्नल टू नॉइज रेशियो, इज जो पॉजिटिव टर्म्स है, मतलब PT GT. PT इज ट्रांसमिटेड पावर, जो पावर हमें ट्रांसमिट करना है थ्रू और बाय यूजिंग अ ट्रांसमिटिंग एंटेना, दैट इज PT GT इज द गेन ऑफ ट्रांसमिटिंग एंटेना. ये पॉजिटिव फैक्टर्स है. एज वेल एज रिसीविंग साइड में जो एंटेना यूज कर रहे हैं, मतलब मोबाइल हैंडसेट का जो एंटेना है, दैट प्रोवाइड सर्टेन गेन टू द सिग्नल, दैट इज अगेन कंसिडर्ड इट एज पॉजिटिव. बाकी सब फैक्टर्स माइनस में लिखे हैं. सो ऑल फैक्टर्स व्हिच आई हैव लिस्टेड इन दिस लिस्ट आर रिटन एज द माइनस. अब देखो डिजाइनिंग कैसे करते हैं. by using this formula पहले ये decide करते हैं कि what should be the required signal to noise ratio. So this much amount of signal to the noise ratio is required at the receiving side, and accordingly the value of transmitted power is calculated. So from this equation I can well write the equation of transmitted power. देखो ये PT यहाँ पे बाकी सब terms RHS LHS में transfer करेंगे, so it becomes SNR minus GT plus L50 plus M minus GR plus LE plus N plus I. N plus I is receiver noise plus interference. So by making use of this formula, it is decided ki how much amount of power should be transmitted by the transmitting antenna, and accordingly the transmitting antenna is designed. Next part is some important terms related to teletraffic. Teletraffic, as the name indicates, it is telephone traffic, or in this case you can say it is mobile phone traffic. So first term is trunk. As I mentioned earlier, these terms are important from the exam point of view, and apart from this, numericals are expected related to these definitions. First term is trunk. It describes entity that carries one call. मतलब the thing which is carrying, which is responsible for completing or carrying a call, mobile call, is called trunk. Next is trunking. It is referred to the different arrangements of trunks. मतलब जो circuit है, जो पूरा चीज है, the thing which is responsible for completing the call, that is a trunk, as well as switches. Switches means by default digital switches. Then next is traffic. It is average number of calls in progress. Next, busy hour. So it is related to 1 hour period of entire day, which corresponds to peak, मतलब maximum traffic load. तो दिन में कौन से hour में maximum traffic है, that represents the busy hour. Then related to busy hour, one more term, important term rather, is BHCR, busy hour calling rate. It is ratio of average, AVG means average busy hour calls, मतलब busy hours में कितने average calls है, divided by number of subscribers, that is denoted by N. Next is holding time. अब देखो ये confusing है थोड़ा, ऐसे याद रख लो. Holding time is not the time period for which your call is put on hold by the system or by the network, but it is representing the duration of a call. Next is blocked or lost call. This is well-known phenomena. We in our common life we use this word again and again. So simply it is, if your call is not getting completed due to the network congestion, then it is blocked or lost call. Next definitions. Traffic carried is the traffic carried by group of trunks. It is denoted by A, and its formula is HC upon T. Here I have written the meanings of each notation. H is average holding time, C is average number of calls in particular time period, and T, capital T, stands for time period. Then call completion rate, it is CCR. Very simple, number of successful calls. It is ratio of number of successful calls to the number of calls attempt. अभी मैंने एक्सप्लेन किया कि बहुत बार ऐसा होता है नेटवर्क कंजेक्शन की वजह से योर कॉल इज ब्लॉक्ड और योर कॉल इज लॉस्ट. सो नंबर ऑफ सक्सेसफुल कॉल्स टू द नंबर ऑफ कॉल्स अटेम्प्ट, दैट रेशियो इज CCR. देन ग्रेड ऑफ सर्विस, GOS, इट मेजर्स, it is basically measurement of network congestion, and it is given by the formula traffic lost. It is ratio of traffic lost to the traffic offered. Then important part is how the traffic is measured. The unit of traffic is hour-length. A server is having 1 hour-length of traffic if it is engaged for entire period of observation. Very simple definition, and do remember this formula. 1 hour-length, जैसे मैंने बताया, hour-length is the unit to measure the traffic, is 3600 call seconds or 60 call minutes. बाकी और भी थोड़े टर्म्स हैं that we will discuss while solving the numericals. Now let us solve few numericals. I have made a complete list of formulae. इतने फॉर्मूले आप लोगों को चाहिए to solve the numericals. लेकिन ये numericals simple है, direct formula based है, so such numericals you should not skip from the exam point of view. So first numerical, during busy hours 1200 calls were offered to the group of trunks and 6 were lost. मतलब 6 calls were lost out of 1200 calls. The average call duration is 3 minutes. This is the average call duration. Fine. First part, traffic offered, then traffic carried, traffic lost, grade of service that is GOS, and total duration of congestion. अब पहला कैलकुलेशन मैंने करके रखा है. Traffic offered is A is HC upon T. Look at the formula. A is HC upon T. H means average holding time, C means average number of calls, and T means time period. For the reference, time period is taken as 60. हमेशा रेफरेंस का टाइम पीरियड ए के केस में 60 लेना है. H, value of H is average holding time. So average holding time is 3 minutes, and value of C is average number of calls. Number of calls are 1200. ये मैंने C का वैल्यू पहले लिखा है. So 1200 into 3 upon 60. Answer is 60. Second part. Second part is traffic carried. Let us denote it by, वही ट्रैफिक का फॉर्मूला यूज करना है ए का. Let us denote it by AC. ट्रैफिक कैरिड. अब इसमें C का जो वैल्यूज है, मतलब टोटल तो 1200 कॉल्स है, उसमें से 6 कॉल्स वेर लॉस्ट. तो एक्चुअली कितने कॉल्स कैरी हो गए? दैट इज 1200 माइनस 6, दैट इज 1194. इतने कॉल्स कैरी हो गए हैं. So in this case, I will put the value of C as 1194 into 3 upon 60. That will give me the answer of traffic carried. So this traffic carried will be, this unit of this answer is capital E, that is Erlang. So this answer, if you solve this on the calculator, it is 59.7 Erlang. Third part. Traffic lost, very simple. Traffic lost, let us be denoted by AL. Traffic lost. In this case, जो call lost हो गए उतने ही सिर्फ consider करना है. Total lost calls are 6. So number of calls I will say 6 into 3 upon 60 as it is. वही formula हम लोग use कर रहे हैं. So this answer of traffic lost will be 0.3 Erlang. Now fourth part. Fourth part is grade of service, that is GOS. Look at the formula for grade of service. It is traffic lost divided by, or it is ratio of traffic lost to the traffic offered. So traffic lost and traffic offered, we have all the values. Traffic lost is 0.3 Erlang, and traffic offered, this is traffic offered. This AC stands for traffic carried. So it is 0.3 upon 0.60. E is the unit, so it is 0.005. That is grade of service. And last part, fifth part, total duration of congestion. Total duration of congestion is GOS into 3600, that is 0.005. ये फॉर्मूला मैं यूज कर रहा हूँ. फॉर्मूला नंबर 3, GOS into 3600. So this will give me 3600. This will give me the value of total duration of a call. So total duration of a call was 18 seconds. Next problem, a group of 20 servers carry a traffic of 10 Erlang. If average duration of call is 3 minutes, calculate number of calls put through by single server and group as a whole in 1 hour. So first we will calculate the basic thing. That means we need to calculate traffic per server. So there are 20 servers in all, and traffic per server, total traffic is given as 10 Erlang, so it is 10 upon 20. Traffic per server, very simple, total number of servers are 20, so it is 1 by 2. 1 by 2 Erlang is the traffic per server. Now remember, this 1 by 2, when we write the unit Erlang, its reference is 60 minutes, because it is per hour. Erlang is referred to per hour. That's why in the last problem also we took value of t is equals to 60, that is 60 minutes. So it indicates that for 30 minutes, 1/2 means 1/2 of 60, because E means by default stands for 60 minutes. So 1/2 means 1/2 of 60 minutes, that is for 30 minutes server was busy. Okay, now first part. Number of calls put through by single server. So number of calls put through by single server is calculated in a simple way as 30, that is 30 minutes upon 3 minutes. What is this 3 minutes? Average call duration. So total duration available is 30 minutes divided by average call duration, that is 3. So it will give me the number of calls put through by a single server. So by a single server, 10 number of calls will be put through. Now remaining part, how many number of calls put through as a whole in 1 hour? We are talking about 60 minutes, that is by default it is 1 hour. So for the for the next part, that is number of calls carried by or put through by a group of all servers is 10 calls, it is per server into 20, that is number of servers, so it is 1200 calls are put through as a whole by the group. Next problem, over 20 minutes observation interval, 40 subscribers, so number of subscribers are 40, initiates a call. Total duration of call is 4800 seconds. Calculate load offered to the network by subscribers and average subscriber traffic. मतलब क्या क्या calculate करना है? Load offered to the network by subscribers, मतलब सब्सक्राइबर ने कितना लोड ऑफर किया टू द नेटवर्क, एंड एवरेज सब्सक्राइबर ट्रैफिक. अब देखो, वी हैव द लिस्ट ऑफ फॉर्मूला. लेट अस फर्स्ट कैलकुलेट, यूज फॉर्मूला नंबर 4 टू कैलकुलेट वैल्यू ऑफ सी. C gives you the mean call arrival rate. Mean call arrival rate. Look at the formula. It is number of subscribers upon observation time. So number of subscribers are 40. Observation time is 20 minutes. So this gives me 2 calls per minute. So what we did, we have calculated mean call arrival rate, that is 2 calls per minute. Now look at the fifth formula, mean holding time, that is MH. Mean holding time, which is MH, is equals to total duration of calls upon N. Total duration of calls is 4800. It is given in seconds, so I need to convert it into minutes. So divided by 60, because given value is in seconds, I have to convert it into minutes. So 4800 total number of total duration of calls divided by 60, and look at the formula, divided by N. So value of N, total number of subscribers, is 40. So if you solve this, you will get this answer as 2 minutes per call. Now next part, traffic offered is given as A into C. So I will write it here, traffic offered is A into C. Look at the formula of A, don't get confused. It is SC upon T, where T we took in the last numerical, in the first numerical also we took at 60 minutes. We already considered this value, we have converted the things into minutes. So in this case, simply the traffic offered will be this 2 into 2. So traffic offered will be this 2 into 2, that is equals to 4 Erlang. Now last part, look at the formula. What we have to calculate, average subscriber traffic. So average subscriber traffic is A by N. So average subscriber traffic is 4 Erlang upon number of users, a number of subscribers, that is 40. So it is 1 by 10 Erlang. So this is the, that is 0.1 Erlang. So this is the traffic offered. In this case also, don't get confused as far as notations are concerned. So I have calculated traffic offered by taking multiplication of these two, because what I mentioned, basic formula is SC upon T. We use same formula, but we have already considered T. So this is the last answer, traffic offered is 1 by 10. So dear students, I have covered maximum possible variations of such numericals. So that's it for today's session. So thank you. Thanks a lot for watching this video.